Our equation for number 12 is y equals 1/2 x minus 6. Now, when I make my t-table, it's already in y equals form. So a t-table is probably the easiest way to graph this so far, at least. Easiest value to put in the t-table?
X. 0.
0, right? Because if x is 0, then this thing goes away, right? Which leaves me with y equals minus or negative 6, right? So, if x is 0, y equals negative 6. That's one of my values. Now, I need to pick other values for x. One recommendation here is I really don't want to use 1.
Why?
Can anyone tell me why 1 is not a good choice? Okay, raise your hand. Okay, Kaylee.
We should use even numbers so it comes out as a whole number.
Okay. Remember we talked about how to clear a fraction when we were doing standard form? Okay. This has a denominator of 2, so a nice thing to multiply would be 2. Okay. So if I let 2 be x, then 1/2 times 2 is 1. And 1 minus 6 is negative 5. Now, if I plugged in 1, then I would have had 1/2 times 1, which would be 1/2 minus 6 is negative 5.5. The pain in the butt about that is now you have to graph 1/2 negative 5.5. And it's going to be in between lines, and it's not going to be as exact. So we'd rather not do that. So what would be another good value for x then? 4, okay? Because if 2 clears the fraction, any multiple of 2 will clear the fraction. If I had a fraction that was 1/3, if I had like 1/3 x, good choices for x would be 3, 6, 9, any multiple of 3, right? So if I use 2, then another good choice would be 4. And 1/2 times 4 is 2. And 2 minus 6 is negative 4. So now I have 3 points. Yes, question?
So, would that be like a pattern basically where it just keeps going down?
Yeah. Does this look similar to like maybe section 8-2? I mean, as these are increasing by 2, these are going down by 1. We have an arithmetic sequence here. Yes? Ring any bells? Okay. Okay. That's what this is. Doesn't this look like the rules we were writing from those sequences? I mean, that's the reason why the beginning of this chapter we start with sequences. Because linear equations are sequences. They're something that's growing in a continuous way. In fact, section 8-4, which you're going to watch the video on this weekend, is rate of change. It's talking about something growing or changing at the same rate. Okay? So, that's what we see here. We see a pattern because it's changing in the same way. Every 2 units here, it's going down by 1 unit here. All right, so now we have 3 points, which is, I recommend at least 3. You can always do more, but at least 3. And then we can graph it. So, if I have this graph, and I need to graph 0, negative 6. So I go left to right none and down 6. And then I have 2, negative 5, so I go to the right 1, 2, and down 5. And then I have 4, negative 4, so I go to the right 4 and down 4. Do those 3 points lay on a line?
Yes.
Yeah, they're a straight line. So we can connect those. And also,
It goes forever.
you should draw your arrows so you know, hey, this line doesn't, it's not a line segment. It's not from here to here. It's from infinite ways this way to infinite ways that way, right? So the arrows just tell you that, hey, this line extends forever, which is why it has infinite numbers of solutions. Hannah, question?
Can you go over the 10?
Uh-huh. All right, so let's look at number 10 next.
Because I got confused because there was no X value and I got like.
Okay.
Those were easy.
Yeah, really, those are actually the easiest ones. But if you're not used to them, I'm not saying, making fun of you, saying, oh, that's easy. I can't believe you missed it. They're different. So, but once you know how to do them, they really are the easiest ones because you're not having to plug in values. If you look, number 10, we have y equals 7. Well, when does y equal 7?
Always.
All the time. What can x be?
Anything.
Anything. So,
I put a million.
you could make a t-table. Technically, you don't even really have to make a t-table.
No, I'm not even joking.
0, 1, 2, whatever. Well, let's see. If x is 0, what is y?
7.
Oh, yeah, that's right, 7. If x is 1, what is y?
7.
Oh, yeah, it's still 7. What about if x is 2? What's y?
7.
7. Okay, so we get how that's easy because, hey, in this case, y doesn't really depend on x because x isn't even part of the equation. No matter what x is, y is 7.
Snickles. I put a million.
You can do that. That's fine. All right, now, and really, when it gets to it, once you get used to these, you really don't need a t-table for y equals 7 or for x equals something. Because what you should really know about y equals 7 is that y equals 7 is going to be, let's see, let me do a line here so we can see it. So let's say, here's my graph. So where does y equal 7? Well, y equals 7 at 0, 7, which is here. It also equals 7 at 1, 7, which is here, and at 2, 7, which is here, and at 3, 7, and 4, 7, and negative 1, 7, and negative 2, 7, and
8, 7.
all of those are
They're all.
on that line, right? Here's what you should know about an equation y equals anything. If y equals a number, that is always going to be a horizontal line. Okay? It's going to be parallel to the x-axis because the x-axis is the line y equals 0. I mean, what's the y value here?
0.
What's the y value here?
0.
What's the y value here?
0.
That's why our x-intercept is where y equals 0, because anywhere on the x-intercept, y would equal 0. So the equation for this line is y equals 0. This line right here is y equals 1,
2.
y equals 2, y equals 3, y equals negative 1, y equals negative 3. Okay, we get the point. All those horizontal lines are y equals some number, because y just tells us our height, and if you have a horizontal line, it always has the same height, right? You know, a line that's slanted is going to change. The y value here is going to be smaller, the y value over here is going to be bigger, right? Okay, but if you have a line that is horizontal, its y value stays the same. So, anytime you see a y equals line, that you, without even making a t-table, you should know that's a horizontal line. And of course, the reverse is, anytime you see an x equals, then that should tell us automatically it's going to be what kind of line?
Vertical line.
Vertical, right? Because again, the y-axis is the line x equals 0. Anywhere on the y-axis, my x value is 0, right? What's the x value here? 1, right? Because we're to the right 1. Anywhere on this line, we're to the right 1. Anywhere here, we're to the left 2, right? So that's x equals negative 2. This is x equals 5. Okay, so any vertical line is going to have an x equals some number. So if I have x equals 3, then that's just count over from the middle, 1, 2, 3, and that line right there is x equals 3, right? So you don't even have to make a t-table. You should basically just have memorized y equals something is a horizontal line that is parallel to the x-axis. So y equals is horizontal to x, x equals is, not horizontal, is parallel to x, and y equals is parallel to x, and x equals is parallel to y. So, all right, any other questions?
Number 4, the one on the computer.
Okay, number 4 from the computer. So for this one, we have x minus 3y equals 9. So we want to find our x-intercept. And what do we know about our x-intercept?
It's gonna, it's,
Y equals 0, right? So if y equals 0, that means this goes away, right? So then that leaves x equals 9, right? So my x-intercept is 9, 0. We're staying here. Don't worry about it.
Pardon this interruption. At this time, all students should return to homeroom to receive their report card. Thank you.
All right.
Let's go to home too.
All right.
And we're not leaving. Home.
All right. The y-intercept. The y-intercept is where
X
x is 0. So that means this goes away. Remember, though, that doesn't mean I'm left with 3y. It means I'm left with negative 3y. So I'd have to divide through by negative 3 on both sides, and I'll get y equals negative 3. So x is 0, y is negative 3. All right. Okay, so, yes, that. From which one? From the workbook? All right. Okay, we're going to do one more real quickly, and then I'll hand out your report cards. All right, number 1, we have y equals x minus 5. And you're just finding 4 solutions, so you're making a t-table. It's already in y equals form. So, guys, now, all right, so, yes.
Do you have a video on putting it into y equals 4?
Yes, that was one of the ones that you guys watched while I was gone. I'll look and stay after class for a second. I'll help you find it. All right, so if x is 0, that's one of the easiest ones. If x is 0, then y is negative 5. If x is 1, then we have 1 minus 5, which is... And if x is 2, then we have 2 minus 5, which is... So... Oh, and we need a 4th one. I forget, this is the ones they were asked for. So 3, and 3 minus 5 gives me negative 2. So there's 4 values. Again, you might have had different values, but those were 4 values that were pretty easy to find. All right.